Alright, Algebra 1, here we go. This is your Unit 4 and 5 test review. And again, we combine these two Units 4 and 5 into one test because they are both pretty small sections. So let's just go through these problems here. So we're going to start off with some solving and graphing inequalities. And then we'll get into compound inequalities, absolute value inequalities, and then we'll do the sequences, patterns, domain and range, all that stuff that we did in Unit 5. So when we are solving, first of all, we got to solve before we can graph. So when we're solving our inequalities, just like equations, we want to move the number that does not have a variable. So I'm going to move that 2. It's a positive 2, so I will subtract 2 from both sides. 2 minus 2 is 0. Left-hand side is 10a is greater than or equal to. Negative 78 minus 2 is a negative 80. Next step, to get a by itself, we're going to divide by 10 on both sides. Divide by 10. 10 divided by 10 is 1. So I have 1a is greater than or equal to. Negative 80 divided by 10 is negative 8. Now we don't flip the sign here because the only time we flip the inequality is when the number in front of the variable is negative. Just because this 80 was negative, that does not mean we flip our inequality. So a is greater than or equal to negative 8. Now we got to graph this. So we put our number line. We're going to put the number that we just solved for in the middle. One number greater than it on the right. One number less than it on the left. We will shade in a filled in circle because it has the line underneath the inequality. So this is a filled in circle at negative 8. And all the numbers greater than negative 8 are the ones to the right. Number 2. We're getting into a few more steps, but still trying to solve this. So my left-hand side, I can't do anything with that yet. My right-hand side, I need to distribute. So I'm going to take this negative 3 and I'm going to multiply that through. Negative 3 times m is a negative 3m. And a negative 3 times a negative 8 is a positive 24. Next step on my right hand side, again, well, first of all, left hand side, we can't do anything with this. My right hand side, though, I do have some like terms. I have a negative 7 and a positive 24. So I'm going to, first of all, bring down the negative 3m. Negative 7 plus 24 gives me a positive 17. Now both sides are cleaned up. The only thing I can do now is start moving things around. So I'm going to move the variable to the left, so that means adding 3m. So add 3m to both sides. Left-hand side is 13 plus, remember this is like a 1m, so 1m plus 3m is 4m. Is greater than or equal to, negative 3m plus 3m is 0, so those are gone. And then I have a positive 17, which I'll just write 17. Next, I want to move the number with no variable over, so that's a positive 13, so I will do the opposite and subtract. So I'm going to subtract 13 from both sides. 13 minus 13 is 0. I have a positive 4m, which I'll just write 4m, is greater than or equal to 17 minus 13 is 4. Last step, I will divide both sides by 4, and I get that m is greater than or equal to 1. M is greater than or equal to 1. Now we got to graph this. So I put my number line down, put the number I just solved for in the middle, one number less than it on the left, one number greater than that number on the right. At 1, I will put a circle, and since this has the or equal to, it's a filled in circle. And I will shade to the right. Next, again, same thing here. We have parentheses, which means distributive property. So I will take the 4 and distribute this through. 4 times 6m is 24m. 4 times 7 is 28. And then I will rewrite the rest of this. I have a plus 8 is less than, and my right hand side, I cannot do anything with this just yet. I will start moving stuff around eventually, but not right now. Next, combine like terms. So on my left hand side, I got a 28 plus 8 So on my left-hand side, I have 24m, and 28 plus 8 gives me 36. So there's combining my like terms to get the 36. Excuse me, is less than my right-hand side, 36 plus 5m. Again, I cannot do anything with that yet. Next, I will move my variable to the left. So this is a positive 5m. I will do the opposite and subtract 5m. Subtract 5m. 5m minus 5m is 0, so I'm going to cross those out. 24m minus 5m gives me 19m. Bring down my plus 36 is less than 36. Now I will move the number with no variable, which means moving this 36. So I will subtract 36 from both sides. 19m, we bring that down. 36 minus 36 is 0, is less than, again over here, 36 minus 36 is 0. So I will fill that in. Now I know some of you are looking at this and you're saying, alright, 19 is less than 0, that's false, so no solution. But remember, the no solution in all real numbers, it only occurs when we get rid of the variable. I did not get rid of the variable here, so I will divide by 19, and I get m is less than 0. Okay, so you want to make sure that you're aware of what's happening there. You know, make sure that you know when is IMS, well, not IMS for inequalities, we say all real numbers, or no solution, when is that a possible answer, and that's only when the variables cancel out, okay? So we did not have that here. We still had a variable left, so we solved for it. So I'm going to put that number in the middle, so I put 0 in the middle, one number greater than it on the right, one number less than it on the left. At 0, I will put a circle. There's my dot, or the point, whatever. And I will leave it open because there is no line underneath this. There's no or equal to. So shading to the left, all the numbers less than 0 would be those to the left. Alright, now the next couple problems we have are compound inequalities. So compound inequalities, these are the and the or statements. If they're written like this in a string, it's an and inequality, and we know that we're going to have our two circles, whether they're open or closed, whatever, and shaded in between. Okay, so keep that in mind. That's what your answer will look like for your final answer. So let's go through and solve this. Again, we want x by itself. So we move the number with no variable. Now this is a positive 4, so I will do the opposite and subtract 4. Negative 16 minus 4 is negative 20. Is less than or equal to 4 minus 4 is 0. In the middle here, I'm going to bring down the negative 4x. Okay, we don't want to forget the negative sign that's in front of that. Is less than or equal to 12 minus 4 is 8. The last step to get x by itself is to divide by the number in front of it. So I'm going to divide by a negative 4. Now, I'm dividing by a negative, so I need to make sure that I flip my inequalities. And again, I like to show that just by saying, hey, I divided by a negative here. I got to make sure I flip my inequalities. And then we go through and solve this. So negative 20 divided by negative 4 is a positive 5. Negative 4 divided by negative 4 is 1, so I got 1x. And 8 divided by negative 4 is negative 2. Final answer, to put this on the graph, I'm going to put the smaller number on the left, bigger number on the right. We'll look at my inequalities. They are both or equal to. They both have the filled in circle because they have the line underneath them. So at negative 2, I will put a filled in circle, and at positive 5, I will also put a filled in circle. And since this is an and inequality, I will shade in between. Okay, and again, I know it's an and inequality because it's written as a string of inequalities like this. Alright, next one, we have an or inequality. So, we're going to do these individually. Move the 2, so subtract 2. 2 minus 2 is 0. Cross them out. Bring down my 3r is less than or equal to 17 minus 2 is 15. Let me put a little separator here. Last step to get r by itself is divide by 3. So I will divide both sides by 3. I get r is less than or equal to 5. Over here on this side, I need to move the 8, so I will subtract 8 on both sides. Okay, so on the left-hand side, I have 9r. 8 minus 8 is 0, so those will cancel out. Is greater than 54. 62 minus 8 is 54. The last step, I need to get r by itself, so I'm going to divide by 9, divide both sides by 9, and I end up with r is greater than 6. Now remember, for the OR inequalities, we want to look at these individually. We do not want to just put the dots and shade on the outside because it might not be that way. I'm going to put the smaller number on the left and the bigger number on the right, and then graph them individually. So this one says r is less than or equal to 5. So at 5, I will put a circle and fill it in because we have this line underneath it that says or equal to, and everything less than it is shaded to the left. R is greater than 6 means at 6 I will put in open circle. Greater than means shaded to the right. So there is your final answer for that problem. Alright, now we are getting into the absolute values. Now remember, for the absolute value inequalities you have to set up these will always have two inequalities. Okay, one of them will be what you get just by dropping the absolute value bars. So negative 10 plus 6n is greater than or equal to 4. This is where you have to remember the other part, which I told you, that little acronym goal. Greater than means or. Okay, that's what this part here means. Greater than means or. And the second part is and is for less than. So what I'm going to do then is look at my inequality. Since this is a greater than, I know it's an or statement. And then what we do for the other part is recopy the stuff inside the absolute value bars. We flip the inequality and we make that other number negative. Alright, and we're flipping this because we multiply by a negative. So we flip the inequality, make it face the other way, and we make this number opposite, so negative 4. Alright, now we're going to solve them. So we have to get the variable by itself. This is once you get your two inequalities written, it's no different than the compound inequality. So add 10 to both sides. Add 10. Negative 10 plus 10 is 0. Bring down your 6n is greater than or equal to 14. Divided by 6, divided by 6. And I had some of you asking me yesterday, what do I do if I end up getting a decimal? Do I just round to one decimal place, or what do I do? My suggestion is to leave it either as a mixed number or an improper fraction. So I'm going to write this as 2 1/3. You could also write this as 7 over 3. I would not write it as 2. I would not write it as 2.3 repeating. Leave it as 2 1/3. Leave it in the fraction form. And I'll show you how we handle that when we get into the graphing part then. Typically almost every absolute value inequality, when you see something like this with the absolute value bars, they will almost always have one of them being a decimal. Okay, so almost always one of them will come out to be a fraction. Alright, other inequality, let's solve this one. We're going to do the same steps. Add 10. Negative 10 plus 10 is 0. Bring down the 6n is less than or equal to negative 4 plus 10 is 6. Divide both sides by 6, and we get n is less than or equal to 1. Okay, and another thing I want to point out to you is, like, look here, we did the same thing in both steps. First step we added 10, second step we divided by 6. So your absolute value inequalities should look almost identical when you're solving them. All right, now when we graph this, so this is what I was saying here, this is what your graph should look like when you have a fraction. We put our smaller number on the left, and you can do one of two things. You can, sometimes we'll just put a 2 and then mark it off, like right here would be like 2 1/3. Or you can just mark it as 2 1/3, and you don't need to have two different marks there. So it doesn't really matter what you do. Okay, you can kind of take your pick there. It doesn't make a difference. You're going to be looking at your multiple choice answers and finding the right answer anyway. So it doesn't really matter how we have that. So let's graph these individually now. N is greater than or equal to 2 1/3. So at 2 1/3, I will put a filled in circle. And greater than or equal to means shade to the right. N is less than or equal to 1 means at 1 I will put a filled in circle and shade to the left. So that's what your final answer should look like. Alright, another absolute value inequality. Again, one of your parts will always be just dropping the absolute value bars. The other part is dropping the absolute value bars, flipping the inequality, and making that other number negative. Now, what do we connect this with? Well, this is a less than. Okay, less than means and. And now we're just solving this like we solve any other inequality. So go through here. First of all, we're going to move the 1 over, so add 1 to both sides. Negative 1 plus 1 is 0. I'm left with 2x is less than 7 plus 1 is 8. Divide both sides by 2, and I get x is less than 4. Again, same steps. So we're going to add 1, divide by 2. Same steps here. Add 1. 2x, negative 1 plus 1 is 0, so those are gone, is greater than negative 7 plus 1 is negative 6. Divide by 2. Divide by 2. X is greater than negative 3. So this is one where we actually ended up getting both whole numbers, integers. We didn't end up with any fractions, so that's nice. It does happen every once in a while, but not always. So smaller number on the left, that's my negative 3. Bigger number on the right, that's my positive 4. These are both less than, greater than, which means we're going to leave them as open circles. And since this was an and compound inequality, or we made it an and compound inequality, that means we shade in between. Alright, now that is all of the inequality stuff. Now we're going to move on to sequences, patterns, domain and range, the mapping diagram, stuff like that. So we want to know what are the next 3 terms in this pattern. So 26, 16, 6, negative 4. So hopefully you can see that in each of these steps we are subtracting 10. Alright, so subtract 10. So if I start with negative 4 and I subtract 10, I end up with negative 14. Subtract 10, I get negative 24. And subtract 10 one more time to get negative 34. Alright, so those are your 3 answers. Now, if we wanted to find out this is not part of, that's your answer right there. If we wanted to write our expression to represent this so that we could find out the 100th term or something like that, this is how we would do that. We would say blank times n, which is the number of what number term you're looking for, first, second, third, 50th, 1000th, whatever, plus blank. The number in front of the n is how much this is changing each time. So that would be negative 10. And remember, this number right here is your 0 term, which means the term that comes before this. So if I subtract 10 to go to the right, that means I have to add 10 to go to the left, which means I would be at 36. Okay, so if you are asked to write the equation or write the expression, that is how you do that. All right, so let's go ahead and finish out this next one here. This pattern, negative 1, 1, 3, 5, can be represented right here. They're actually giving you the pattern here. So we're just going to fill in here the 63rd term. So we're going to just multiply this. We're going to say 2 times 63 minus 3. So we just use our calculator. We say 2 times 63 gives us 126. Minus 3 gives you 123. Next, find the domain and range. Now remember, when you're finding domain, it's all of your x coordinates written in order from least to greatest, and if there's any repeated, like the negative 2, we don't need to write that twice, we'll just write it once. Alright, so negative 2, 0, 1 is your domain, and the range is all of your y coordinates. So I have 3, 5, 3, 5, so there's actually only two numbers in the range, which is 3 and 5. And again, we don't have to write that more than once. Using the vertical line test, we want to know, is this graph a relation and or a function? First of all, remember, everything is a relation. So if it says it's neither a relation or if it says function only, that's not even an option. So if we look at the vertical line test, if I draw a vertical line, we can see that this is going to hit the graph more than once. So that means that it is not a function and it is a relation only. Find the perimeter. Again, when we're looking at this is a width and the length. So remember, if we have a perimeter, this is an old problem, that means one of them would be 4x minus 1, which would be both sides. And 2x squared minus 3x plus 4 would be your top and bottom. So to find the perimeter, we would just go around and add up all of those pieces. So the top, 2x squared minus 3x plus 4. The right-hand side would be 4x minus 1. The bottom is another 2x squared minus 3x plus 4. And then this left-hand side is 4x minus 1. So add up your like terms. First of all, my x squareds, I have 2x squared plus 2x squared, which is 4x squared. And my x's, I have a negative 3x, positive 4x, negative 3x, positive 4x, which will give me a positive 2x. And then the last one, I have 4 minus 1 is 3, plus 4 is 7, minus 1 is 6, so plus 6. Alright, so again, like always, if you have any questions, just let us know. Otherwise, those are the type of problems you can expect to see on your test tomorrow.